About your exam on Thursday. So it's getting to be that time of year where we have our third exam, and then we'll be in the home stretch where we can get to our final exam, and so that will be coming up. There's a couple of things I want to address with the class. When I get your emails, and some of you give me a lot more information than other people give me about what's going on in your personal lives, and I feel like I would be remiss if I didn't at least point this out to you. Part of everybody's tuition is that you have access to free counselors in the counseling center. So if you're beginning to feel like this is overwhelming, like this is hurting your personal life, you're having family emergencies, if you're thinking about suicide, I mean, this can be anything from little problems to big problems. You certainly have access to the counseling center, and I would urge you to take that advice, because obviously I'm equipped to talk to you about like biology in this class, but when somebody says to me like, my whole life is falling apart and I feel like I just want to die, I have to obviously address that with a bit more seriousness. So I also am aware that for some people, like if you have a cultural background that says like students, you shouldn't go to counseling, you don't tell people about your problems. I just want to point out to you that going through a university type of setting, you come to rely on experts. You know there are experts in your own field. If you are a business, you're going to go to an accountant. If you are in psychology, you understand having a doctorate in psychology. Someone like me who's getting a doctorate in education, I'm an education expert. Go to the experts if you feel like you need help beyond something like me fixing 10 points on your homework assignments. It's certainly not looked down upon, and if anybody's going to understand the stresses of being in college, it's the people who do counseling for this college or for this university. So please, if nobody's ever talked to you about that before, that's certainly a good resource. And if you have roommates or peers or people you know of here at the university that need that resource, definitely reach out to them, because this could be the start of a year. I call it the fall freakout, where everybody starts freaking out about their grades or whether they're going to pass or whether there's going to be a next semester and things like that. So go to somebody that's an expert in that. And the other thing is, I often get a lot of emails like, I can't get so-and-so to open, I can't open this file, I can't download, I can't watch the videos. I can often not assess what's going on with your computer system, but the Springboard Help Desk can. So if you're having issues with your computer, your mobile device, with Springboard, with watching the videos and things like that, 6888 is the number for the help desk. And I will tell you, some days I'm on there multiple times calling the help desk trying to figure out what's going on. So they are really, really good at diagnosing these problems. Whereas I might not be able to help you figure out, I can figure out some things, but often I can't figure that out. So I wanted to point out to you what the university counseling site looks like. They have some resources on there for college students if you feel like you need further help or want to look and see what kind of services they offer. They also do things like drug and alcohol counseling or suicide prevention and things like that. So if you don't know that that's one of your resources, now you know. And if you don't know that there's a help desk for computer issues, then now you know. And I hope that you've heard those things before, but if I'm the first one to tell you, then at least I got a chance to tell you. So if you want to talk to me about that anymore afterwards, definitely let me know. So like I said, sometimes students don't know who to ask for help, and I think that that's one of the problems that we get into. We think that we're alone, or we think that we don't know what we're going to do. And I totally get that, and like I said, I reach out for help all the time. If I didn't reach out and make those connections, I would probably be berserk at this point. So even I have called the counseling center and said, I'm having health problems, how do I get past that? And they've talked to me about, what to do with my health problems. And I call for Springboard help like sometimes daily. So don't be afraid to ask for help, and just so you know, even me as a student, I'm not afraid to ask for help either. So getting a little bit more into our test that is on Thursday. As usual, it will be open from 9 a.m. to 8 p.m. on Thursday. It'll be in the computer-based testing center, and you need to make sure that you have your zip card with you. And I've heard some students say, I can't go down there and do this because I don't have my zip card. Bring your zip card with you. I don't know why you would ever not have it with you. In fact, I keep mine stuck on my keys at all times so that I always have that, and I always have that option. And so I was going to talk with you guys a little bit further about the format of the test. Some of you had said that the 60 questions was overwhelming or that it was too much, and so I was going to take a vote with you guys. It's your choice how you would like to have this. I can either put only 45 questions on the test and not plan to drop anything, or I can give you the 60 questions and then I drop the ones that go below 35%. So I would like to let you think about that for just a second. If you want to ask your neighbor, what do you guys think would be the best strategy? Go ahead and take a minute and think about how you're going to vote, and then I'm going to take a vote with y'all and see how you feel about that. I grew up here, and I went to Norton High School, and then I went to Mount Union College, and then I went and lived on the Mexican border for 10 years. So I do have the y'all thing going on, but I also kind of pepper it with a little bit of Spanglish, so I don't know. I could, yeah. Or carry my groceries in a buggy, yeah. Yeah. I can't get used to like grocery sacks, though. I think sack is a funny word. So, all right. So yes, you have a question. So there are going to be 2 finals that will be offered during final exam period. There will be one that will just be that final 4th of the class, and then I'm offering a cumulative makeup final. So if you miss any of the exams for any reason, or you got a really low score on one of the exams, I'm going to offer a cumulative final for anybody that wants to at least attempt it. So there would be 2 exams open that final week.
Now, I noticed that it said the final is on Thursday from like 6 to 7.
It'll be the same thing. It'll be on the Thursday that whole day. Yeah.
Is that for both tests?
The cumulative final I'll probably make open that day and another day, because I don't want you to take them both on the same day. That would be horrible. So maybe I'll make it open like Tuesday through Thursday or something. And there was another question?
Yes, I was having trouble downloading my study guide.
Okay. That would be one of those cases where it would be called the Springboard Help Desk, because I don't have any idea what browser you're using or how you get into Springboard. So I hadn't heard that before, but I'll definitely help you to get that. Yes, I will post a new one after class today, because it'll just be over what we finish up in class today. So, yes. Yes, you can take both of them. And you can try the cumulative one, and if it replaces your lowest test score, then great. And if it's lower, then I'll toss that one out. So, it would give you an opportunity to have 5 tests instead of 4 tests. Anybody else? Okay, so with a show of hands, how many of you would like to have 45 questions on the next test? Okay. And then just to kind of get a feeling, how many of you would like to have 60? Okay. All right. Thank you very much, and I will get that worked out for you, so that if there's any further questions, I'll make sure to put that on Springboard. So some suggestions that I got as far as reading your plans for the YouTube videos and looking at or the plans for the studying for this final test. I heard some really great things that some of you do, and I wanted to share those with the class. One of the things I often heard is I plan to skim the chapters. If you're not reading the chapters and you're not at least figuring out which parts are relevant and which parts need to supplement your notes, just skimming the chapters is not a really great strategy. What I know as far as education goes is that if you don't actually read them and try and make sense of them, skimming them is often not very helpful. And I know that if you're a skimmer, you're probably not going to listen to that, but skimming a text is not really a good strategy. I hope that when you are studying, you're doing so in a non-distracted environment. Block Facebook if that's what you need to do. There is actually a browser extension that you can put on your browser, like your Firefox, Internet Explorer, Chrome, that will block Facebook so that you cannot actually get to it. And I actually do that with myself because that's my biggest problem, is that I start looking on Facebook and then I can't ever get off of it. Me as a student, I know that's one of my strategies. I have to actually block myself from Facebook because otherwise I will mess around all day. One of the things I heard from students is that some of them are using online tools or mobile tools such as Quizlet.com or StudyBlue.com, and what they do is they help to make mobile flashcards so that you can be flipping through your phone and looking for those things. And I think that those are great ideas. I hadn't heard of either one of those before, but I checked them both out, and they both look like they're a good idea. If you bought one of the new textbooks, you have access to PrepU. You can go through and look through and do quiz questions and check for understanding through the textbook manufacturer. And one of the best strategies that I found, like I actually wrote on your study guide, Google what you don't know. Google things like, how do I pass a college biology exam, or what's the best program to study, or test-taking strategies, or I have test anxiety. Sometimes people don't know what kind of search terms to put in there, so just Google them like you think of them, and that's often a good way to start trying to figure out what you're trying to figure out, and then looking for things that connect to that. There's some great strategies out there, but also try not to get so hung up on strategies that you don't think like maybe you just need to put the good old-fashioned work into it. Maybe you need to spend that time, and you know whether you study well with others or whether you study well on your own. You know if you're going to do it at your house or if it's better to come do it here in the library. There are definitely lots of different strategies, and I really enjoyed reading them. They actually made me really, really happy. I would thought that was pretty awesome. So as I was reading your study plans, I was pretty inspired by it. Thought that some of you are doing amazing jobs with the resources that you're given. Some of us have kids. Some of us have full-time jobs. Some of us have all these stressors in our lives, and I think that you guys are an amazing group of people who are trying to get stuff done. And so I give you a lot of credit for that, and I thank you for that. So before I move on into what we're actually going to study today, is there anything you want me to cover before I move on? Yes?
I just happened to look on the springboard. You had a Dropbox open for something that was missed.
Yes. I am glad that you said that. In fact, I think yes. I'll have the completed study guide up tonight, and there is a Dropbox that's open. I believe I made it open until Friday at noon. That is for any of your missing assignments. So like if I said I couldn't open it because of the format, or if I said that it wasn't thorough, or you didn't get some of the points, if you got a 0 on it, upload one of your good ones to that, and that'll make up for any zeros or any low grades. And yes, they should all still be posted, and so yes, if you didn't do an assignment because you missed one of them, or you forgot, or had problems, whichever one you want, you can upload to that Dropbox. And so there's an opportunity to make up for a grade. Does that answer your question? Okay.
In the Dropbox, it has like the makeup
Oh, yeah,
The
the
makeup
30.
assignment, it says 0. Are you just like not counting that if we didn't turn everything in for the makeup assignment?
Oh yeah, it won't count against you if you didn't have to do a makeup assignment. It won't count against you. So it may say something like 90 points out of 100 or something like that. It won't be out of 100. It'll just be out of 90. So it may have counted towards the total, but just think if you got all of them in, then you're good to go. Yeah, yeah. Yes. Yes, sir.
That's only one assignment. Right?
Yeah, yeah, yeah. Yes.
On the, we have the test grades out.
Yes.
It shows that the makeup test grade is like part of like the total amount of.
Yeah, it won't count towards you in the end because I'll use an Excel spreadsheet to figure out your grades, and so I'll count them up separate than Springboard. Springboard's kind of actually hard to work with when it comes to doing like bonuses and makeups and stuff like that. So I'll figure it out on an Excel spreadsheet, and I'll give you the Excel spreadsheet so you can figure it out too. In fact, if somebody can email me, I'll post the Excel spreadsheet so you can check it now. So if any of you want to email me and see how you're doing so far, I'll send you the Excel spreadsheet or I'll post it on Springboard as long as somebody reminds me. I never remember anything I don't write down. So somebody email me. Anybody else? Okay. So continuing on with what we had talked about in the videos, we've been talking a little bit about evolution and how different types of organisms can develop characteristics if some of those characteristics don't seem to be beneficial. And so you saw this slide the last time where we were looking at how could you possibly develop wings if 1% of a wing isn't going to be a helpful adaptation. And so you saw this slide where they had 1% of a wing give some thermodynamic benefits, like helps the insect to regulate its heat. And so as it starts to grow more and more wings, it helps it regulate its heat better and better. And then at a certain point, that wing helps the organism to glide, and then eventually the wing is that adaptation for flying. And so some structures start out with other reasons for it in mind, and then they move on to become beneficial in a way they weren't originally meant to be. What we often find in organisms is that those, especially in hot regions, those that have wings in hot regions are going to have the largest size of wings. And so that's part of what helps to bolster or add up this argument for evolution, is that in the hottest regions we see the organisms with the biggest wings. So the biggest benefit, the biggest thermodynamic benefit comes in these areas where it needs to have that thermal regulation the most, the hottest places. And then also you don't tend to see a whole lot of insects in really, really cold regions for precisely the same reason, because they lose their heat too easily. As we start to look out in nature and start to understand some of the adaptations, we can see that the evidence for evolution is really overwhelming. This is one of my favorite pictures because it shows the way a chameleon is camouflaged to the background. And as all of you know, probably from watching the Discovery Channel or even different cartoons as you were a kid, that these chameleons are so good at blending into their background that they can actually change colors and change the patterns on their skin in order to blend into the background. So animals are really amazing in the amount of adaptations that they show in order to not be seen by predators and in order to become predators themselves. This was an interesting quote that I found on the internet. That comes from Pope John Paul II, so one of the leaders of the Catholic Church, that said that it was remarkable that that evolution had been accepted by researchers because of all the connections that it's made in the various fields. It's not just biology where we talk about evolution. We also look at it in chemistry, in physics, in astronomy. We look at it in the geosciences. We look at it in so many different fields. And not because we ever sought out to prove something wrong, but just because we went through and we looked at the evidence and we said, what does the evidence build up to? And as we started off looking at ourselves and looking at our past, at the bones of our ancestors, we started to learn so much about how humans were able to survive and adapt in the different climates and in the different environments that they live in. And so much so that evolution is accepted by the Catholic Church today because science has presented such an overwhelming argument for that. The 5 primary lines of evidence that we have for evolution, and I would know these, I would know the understanding behind these. First of all, when we go out and look at the fossil record, look at the changes in the things that have been fossilized, the organisms that have been fossilized. And of course you have to think, well, what kind of things become fossils? And that would be things like bones and teeth and shells and imprints of organisms. By looking at all of these petrified fossils, we're able to see such an interesting way of understanding the way the Earth has changed over time. Looking at biogeography, which is the way that organisms are related to each other in specific regions. So, for example, where we had talked about the finches in the Galapagos Islands were very similar to the finches in South America. We can see these relations between organisms that live close to one another. You can see that in a lot of different species, and as we travel back and look at the way the continents have moved around and shifted because of plate tectonics and because of if you look all the way back at like Pangea, where all the continents were attached to one another, you can see the way the development of organisms has spread out among the Earth and is really fascinating. We also look at comparative anatomy and embryology, the way that in the anatomy, some bones are similar among like mammals and our close ancestors, and look at the things that we have in common. And embryology is the study of embryos, so looking at the way they develop inside of the egg, and we'll look at that coming up here in a minute. Molecular biology is studying the DNA and the DNA patterns and the way that they shift depending upon what organism they came from with a common ancestor, and the way that they have shifted depending on their heritage. And then we can also look at laboratory and field experiments, like what we talked about with the fruit flies and the starvation experiment and things like that. We actually have some really amazing experiments going on here at the University of Akron in the biology department. There's one professor who studies fossilized feathers and has actually told us some of the colors that the dinosaurs were based on the fact that certain dinosaurs are found to have had feathers, and looking at what colors they might have been based on their molecules and the melanin in the feathers. So he's the first one to have told us that a certain dinosaur had a black and white color with a red fringed head. It's really fascinating to look at his research. There's others that do studies on bacteria and the evolution of antibiotic resistance. We have another one that's doing the evolution of shrimp and the way that they have spread out among the globe, and they exist in different types of water. Lots of interesting stuff. You've probably heard about the gecko experiments that are going on here. There's zebrafish experiments, all kinds of really cool stuff. So the fossil record is one of the best documentations that we can think of for looking at natural selection. Fossils are a really great example that's out there that can show us where we have come from and help us to make predictions about where things might be going to. However, the fossil record is a very incomplete record. Because if you think about it, the places that we have found fossils, China is one of the up-and-coming places where they're searching for fossils. They found them in the mountains, in the Andes Mountains, in Tibet. They've found them in Montana. Lots of really cool places that they're digging up fossils. But there's no way we could have possibly dug up all the fossils that are out there, and there's no way that we're going to find every species that has ever been fossilized, because if you think about that, it is just impossible. In order for something to become fossilized, it has to be buried in the sand, it has to be in a watery region, or it has to be covered by like tar. If you think about tar pits, that's where they find a lot of fossils. So not only do they go through some really drastic conditions in order to be fossilized in the first place, then we have to go dig them up and make the fossil record that we have. So it's an incomplete record, and it always will be. There's no way we'll ever understand everything that happened in the past. But we come upon more things every day, and it helps us to understand and put the pieces together of the past. So here you can see some of the primitive dinosaurs that we have been studying. The winged dinosaur on the left is, I believe, Archaeopteryx. It's probably one of the ones you heard my kid talking about. And then look at the things that go into finding these fossils. If you Google any of the professors that study fossils and go out and go on archaeological digs or go on fossil finding expeditions, it's really difficult because fossils are found in parts of the world that are really, really difficult to get to. So then imagine that if you're going to dig up a giant dinosaur, then you have to manage to get it back to your laboratory in pieces. Then it's going to take however many years to dig it apart. And sometimes they're getting these fossils out of the ground using a paintbrush, because if they used a shovel, they would destroy them. So just the methods that they have to go through to find dinosaur fossils or find the fossils of anything is just an amazingly huge hurdle. So then when they find the fossils, there's the question of, well, how old are these? So in Darwin's time, they thought that everything that was deeper in the ground was older, and everything as they went up in the rock layers was going to be younger. And now we know, thanks to geology, the study of the way the Earth shifts around, that sometimes fossils are going to shift up to the top and become exposed to the air. And really the only way to tell how old things are is through a process called radiometric dating. So radiometric dating is going to take fossils and look for radioactive isotopes that are found inside of them. So basically what scientists are able to do is to find an isotope of a chemical inside of the rock, one that they know how long it takes to break down, and as they look for that radioactive chemical, they're able to tell how much of it is left in the sample. So in this case, they look at uranium-238. It has a half-life of 4.5 billion years. So that means in order for half of it to decay, or half of it to break down, it's going to take 4.5 billion years for that to happen. So if you find that chemical in a rock that you're studying, you're going to know that that rock is 4.5 billion years old. So that's an amazing understanding of how we can tell how old different substances are. And uranium is certainly not the only chemical that's found in fossilized rocks that help us to understand how old things are. There's a vast array of chemicals in radiometric dating. So we're basically looking at how things break down over time. We know how fast things break down, so by looking at how much there's left, you can tell how long it's been around for. So one of the best known examples here in North America has been the evolutionary history of horses. And so the evolutionary history of horses is well preserved here in North America. If you look at what's alive today, what we think of as a modern-day horse, it's called equus. So many of you may have heard of equine, like equine veterinarians, people that go out and do vet work on horses. So equus is the modern horse, and we can we can look at the fossils of horses that have come before the modern-day horse, and we can basically trace its lineage back to a period in time. And look, every single one of the ancestors is extinct at this point. And so the only modern horse that we have alive today is of the species equus. And so as we look back in its evolutionary history, we can see that the horse looked very different at different points, because keep in mind, North America didn't always look the way that it does today. And so we have different horses that would have a little bit different shape. They had some of them that would have had a different shape of their hoof, or a different shape of their teeth, a different shape of their head. And as you can see, if we go all the way back in time to where the ancestors of the modern horse are, it was a very, very tiny creature. And so that's about 55 million years ago. And the reason we know that the ancestor of the modern horse is 55 million years old is because we can look at the radiometric dating of how much of those isotopes are left in the bones that are fossilized or turned to stone, and we're able to see what the ancestors are by tracing them back through time. And so that has happened with numerous species. That's also how we know the history of giraffes, the history of reptiles, the history of fishes. We can look at so many different things that have been preserved in the fossil record. And so we know back to 55 million years ago how horses came to North America. Kind of an interesting lineage. And one of the things that you often hear people say when they say evolution didn't happen is that they say, oh, well, there's no intermediate species that show that there's a link between two major parts of the fossil record. So one of those that we actually have found just recently was called Tiktaalik. It was the missing link. This was the ancestor between a lobe-finned fish, so something that spent primarily all of its time in water, would have been a fish like we think of today. Tiktaalik actually had this similar bone structure to its fins right before the right before the early amphibians. So this would have been something that lived part of its life in the water, part of its life on land, and would have been the step that was the predecessor to early amphibians. So this was something that was a really great discovery, because it shows that just because we haven't found it yet doesn't mean we're not going to ever find it. And that's kind of the cool thing about science. Just because we don't understand it yet doesn't mean we won't ever understand it. We've found those things to be true about DNA. If you think about all the discoveries that we're making about DNA, and then releasing people from prison that we were found never committed crimes. Now we're finding things about our evolutionary past that we never could have pictured before. So we are finding these missing links every day. And as we explore our world and get even more technologically advanced, even better at finding fossils, we're going to find amazing things that are out there that will answer questions that we still have today. But there are still questions that may never be answered in our lifetime by science. There are some things that we may never find out, but one of the cool things about science is that we keep trying. So here's another example of species that have distributed out in a geographic pattern. This is a example called the Hawaiian honey creeper. So if you were to go to Hawaii, one of the hallmarks of Hawaii is that it has these beautiful exotic birds. called the honey creepers. And there's lots of different species of honey creepers, and they have this long bill that's very specialized for getting the nectar out of these tropical Hawaiian flowers. And so as scientists have uncovered the fossils of these Hawaiian honey creepers, they have found that they look very similar to the modern mainland finch that's found here in North America. And so the ancestors of the Hawaiian honey creeper are shown to have been just a regular, normal-looking finch that may have migrated out to Hawaii, and as they started to collect the nectar from the beautiful flowers in Hawaii, the ones that had the longer beaks that could reach into the flowers would have been the ones that got the most food, and they get fat and happy, and they have lots of babies with long beaks. And as that goes over tens of hundreds of thousands of generations, these species of birds, and that's one of the reasons that scientists often really love birds, they become so specialized to their environment, and that's one of the reasons that birds are really fun to study, because if you think about the flowers in Hawaii, you have to be able to reach very far inside of these big, long-petaled flowers, and they're often very colorful, so you find colorful birds with very long beaks. And so that would be an example of coevolution. So in this case, history matters. We often have to think about which one of these species might have arrived first. When we look at the different species as they spread out among the Hawaiian Islands being a set of volcanic islands, so at one point in the pretty recent past, the Hawaiian Islands weren't there. They were a series of volcanoes that were erupting underneath the ocean floor, and as they continued to erupt, the lava would pile up and they would move up in the water until eventually the tips of the volcanoes spread up over the top of the water, and as they kept spurting lava, they kept growing in size. And then as the lava started to spread and started to cool, the vegetation would have traveled through the ocean and eventually reached those Hawaiian Islands. And so small little vegetation would have happened first, things like grasses or things that had really small spores. And then as we started to have more and more of these plants, they would start to support more and more animal life that may have traveled across on driftwood or may have traveled across the ocean on the currents or in the air currents. And so we start to see all kinds of amazing things happen as we look into the evolutionary past. And the thing that you should always keep in mind is that as things grow and change, the environment grows and changes. Nothing is ever stable in our environment. We know that 1,000 years from now, and then maybe tens of thousands of years from now, or 100,000 years from now, life on our Earth is going to look much different than it looks right now. And so the species of organisms that are going to be alive thousands of years, or tens of thousands of years, or hundreds of thousands of years, all these generations later, they're going to change to survive and adapt to the environment as it presents itself. And that's often a very violent and very predatory and very cruel thing. Mother Nature is never really very kind. So here's another great example. If you think about our continents that we have here around the Earth, the organisms that you find on North America are very different than the organisms that you're going to find in Australia. Here in North America, we don't have nearly as many marsupial species, but we do have a lot of species that have counterparts that have developed on different continents. Like, for example, here in North America, we have the gray squirrel. In Australia, their Australian counterpart would be the sugar glider, and that would be a marsupial. Marsupial is a large pouch-bearing creature. So they develop inside of a pouch rather than developing inside of a placenta. I don't believe this is North America, but in South America we have a giant anteater. In Australia, the numbat. In North America we have the gray wolf. In Australia they have the Tasmanian wolf. So what we find is that these species may have had a common ancestor at one point, and then as the continents started to split apart and shift and oceans came between them, the ones in North America developed in a different way than the ones in South America. So they're less related to each other, but there is still a common ancestor that we can trace back through the fossil evidence that inhabit similar environments. So if you were to think, well, I couldn't ever possibly have been anything else. That is true. You weren't at any time any other species. But if you looked back not just tens of generations, not just hundreds of generations, what do you think? Thousands or millions of generations could you have had a common ancestor with a fish? So that's what everybody usually thinks. The ancestors that we have traced have actually been thousands of generations ago. So if you even think back to the 1700s, you know that we are very different than the pilgrim species that we may have seen at this point, or of our ancestors that have come from around the globe. But we can actually trace back a common ancestor to the fishes back thousands of generations, not just through fossils, but through DNA evidence, through embryology, and through a lot of study of the molecules that are inside of these bodies. So if you think back even beyond like the pilgrims or our common ancestors, what made humans different at some point? If you think back to your grade school studies, when you think of like Neanderthals or cavemen, or you think about like the Vikings or people that may have lived in tribes many, many years ago, one of the things that we know about humans is that the human species, as it is right now, originated in the Middle Eastern and Northern African region. And one of the things that made ancient humans different than their other common ancestors is that they would have collected shellfish to eat. So that's one of the first things that made us different than any of our other primate ancestors. Primate ancestors would have survived mainly in the plains, mainly eating things like fruits and nuts in the rainforest. But as our primate ancestors started to move out towards the ocean regions, they started to collect shellfish. And shellfish have a chemical in them called DHA. Anybody who's ever had a kid has heard of DHA in baby formula, because it's a fish oil that's supposed to help in brain development. So as our primate ancestors started to collect shellfish, they knew that, well, they didn't know, but what happened at the time is that as they ate that shellfish, that one chemical helped them to develop larger brains than the other primates. Your brain is actually mostly composed of fats, and those fats are what help with the neuron firings in your brain. And so those fats that our ancient ancestors would have eaten are actually what helped us to become smarter than the other primates and helped us to survive in a way that was kind of novel and different. And so mammals have this placenta. If you think about one of the characteristics of mammals, it's that they develop inside of the mother's womb, inside of a placenta. And mammals, when they are first born, drink milk. And so this DHA from shellfish is passed along in the mother's milk. And that's part of what helped humans to become such a smart species. And it's amazing that scientists are able to collect that information to know about what's going on with our ancestors. So as we start to study our ancestors, we can look at these evolutionary trees and study the places that we diverged from our common ancestors. So if you look at where mammals are, where the humans are, and you look at where reptiles are, over 200 million years ago is where reptiles and humans might have shared this common ancestor based on fossil evidence. That's what scientists were able to discover. So then more than 350 million years ago is where they diverged, where reptiles would have went one way and amphibians would have went another way. And then back 400 million years ago is where we would have had a common ancestor that fishes went one way and then the other path that led to amphibians and then reptiles and then mammals went another way. And there's really some amazing familial trees or evolutionary trees. If you just Google evolution at berkeley.edu, they're some of the forerunners in studying these evolutionary trees. We actually have some great people here that study these also. So when we go back and we look at these 5 primary lines of evidence that show how things have grown and adapted and changed thanks to natural selection over a long period of time, we really have this amazing amount of evidence that leads up to change over time, this kind of survival of the fittest. And so I think I already showed that. Okay, so talking about what is embryology. Embryology is studying embryos as they develop inside of the egg, either inside of the mother or the female that lays the egg and then incubates it. So here what we have is 4 different species. We have a shark, a turtle, a human, and a chicken. And as you look at the comparative anatomy, looking at the structures that they have in common, you can see that a shark has gill pouches, and a shark is going to eventually develop and live its life underwater. A turtle also has gill pouches as it develops inside of the placenta, but when a turtle eventually develops, it's eventually going to have lungs. There are no turtles that survive 100% of the time underwater. They all breathe at some point in time. So even though they have gill pouches, they eventually develop lungs. And they also have this bony tail. If you look at humans, they also, as they're developing inside of the mother's placenta, have gill pouches. And we actually have a tail, and as anybody knows that has ever bruised their tailbone, we do have a protein that codes for a tail. And there are a certain number of humans that are born every year that actually don't have that protein that turns off their tail-making proteins. And so they actually have to have their human tail cut off. And so if you look at the internet, there's some great pictures on there of humans that are born with tails. So just looking at this comparative anatomy is really an amazing thing. It reveals that we really do have so much in common with the other organisms out there that have backbones. So we have these similar structures. And one of the first people to study this was Ernst Haeckel in about the 1850s. He actually studied these different species and what they look like really, really early on as they're developing inside of an embryo, and then what they look like at a couple of, at like the 2nd trimester and then the 3rd trimester. So they look so similar at the very beginning, and then eventually the fish develops one way, salamanders develop a different way. The next one I believe is a tortoise. Then we have a chick, a hog, a calf, a rabbit, and a human. And so they all end up looking very distinctly different. But as you study their embryology, the way that they develop inside of the egg, they really have some amazing similarities. And that was one of the developments of modern science. So if I were to ask you a question like this on the exam, chick embryos and human embryos both have gills because, which one would you guess what they were? I'll give you a second to read it.
4.
Okay, so I heard several of you say 4, 1 and 3. The answer is not 4, it's actually just 3. Because if you look at number 1, human embryos and chick embryos, neither one of them breathe through gills during their development. They are all breathing through this placenta during their development. So they may have shared a common ancestor that had gills, but neither a chick nor a human is going to breathe through gills at any point. But they both have gill pouches that are part of their development. They both eventually breathe through lungs, and so neither one of them, neither humans nor chicks, spend any time in the water. So in talking about homologous structures, this is kind of the comparative anatomy structure of biology, where we can look at the bone structures and we can see things that are similar between the species, but that are different based upon how the species is going to survive. So, for example, in humans, if you look at the human arms, you can see we have a humerus that here is represented in the blue. We have a radius and an ulna, and then in our hands we have the phalanges, the metacarpals, and the carpals. And what do humans use their arms to do? They use them to grasp and pick things up. We don't swing through trees. Our shoulders would definitely not take that. But a horse also has a humerus, a radius, and an ulna. It has phalanges and carpals and metacarpals, but they tend to be fused into a hoof. And a horse is going to walk on all 4 of those legs. A bat has the exact same structure, but because a bat glides and flies, its phalanges and carpals and metacarpals are spread out within that wing, and the skin structure is going to be spread throughout. And then a porpoise is going to have very short humerus. It's got the radius and the ulna, and then very long phalanges, metacarpals, and carpals, because it's going to glide and swim through the water. So they all have very similar bone structure, but they do different things, and that's why their bones have eventually become different things. They are adapting to different environments. A human lives in a different environment than a horse, than a bat, than a porpoise. So similar, but they do different things. That's what a homologous structure is. Something that it has a similar bone structure, so it demonstrates there was a common ancestor, but it does different things. So you don't have to write this down. This is just another picture that I wanted to show you. Notice that among many of the similar primates, you can see that they may have come from a common ancestor, because things like the tarsier leaps and clings, so its hand structure has a structure to cling to things like branches and to be able to swing around. A gibbon is going to swing through trees, and so it's developed a hand structure that allows it to hang on with very long fingers. The chimpanzee was one of the primates that we see sometimes using tools. So it's got this hand structure that makes it so that it can pick up and it can grasp things. And then humans are going to actually use tools, be able to pick up and adapt and be able to handle things. And so you can see that we have very similar structures, but depending upon what kind of environment they're living in, they are adapted to do different things. And we see this happen in multitudes of different species. So let me skip this one. One of the things that we're often asked about is organs that we have inside of our body that serve no purpose, but just seem to be there causing problems. Anybody who's ever gotten sick and had their appendix out knows that you don't really need it. Your life doesn't change at all after you have it taken out. So why would we be born with an appendix if it just seems to cause so many problems? So first of all, what the appendix is, it's a little finger-like pouch that comes off the bottom of the large intestine, and it serves no purpose in humans. But at one point in our evolutionary past, it would have served a purpose because an appendix is something that helps to break apart leafy and very hard vegetables and fruits. And this might have gone back to a time when humans were hunters and gatherers, and we would have eaten lots more raw vegetables, lots of hard, crunchy things, lots of fruits. And at that time, it would have been helpful to have an appendix to help further break that down. But at this point, with the diet that we have, the appendix doesn't serve any purpose, but it's still just kind of left over there. Another example of a vestigial organ is the wings of an ostrich. So an ostrich can't fly. Those wings don't serve any purpose, but it's still a bird. At one point, an ostrich would have come from a flying ancestor, but as its legs developed because it was running around, as its long neck developed for it to be able to pick up its food source, and as it found no need to be able to fly around just to get bigger, eventually its wings didn't serve any purpose, but they're still there. Maybe at some point, 100,000 years from now, an ostrich won't have any wings, and it'll be something very, very different. In humans, some of the vestigial organs we see, the tailbone, we don't have any point for having a tail because we walk upright. There's nothing that would help us with a tail at this point. For anybody that's ever had their wisdom teeth out, wisdom teeth would have been great for grinding up plant food sources, but now as we've gotten used to eating meat and we've gotten used to eating processed food, our wisdom teeth are not necessary anymore, and including some of the muscles in the ear. At some point, being able to move your ears so that you could listen for predators would have been a good thing for our ancestors, but at this point, we're not so worried about getting away from those predators. So vestigial organs are organs that we have that serve no purpose at this point, but would have served some point in the back, would have come from our common ancestor. And so I'm going to go ahead and cut off there. If you have any questions about the study guide, I'll put it up tonight. I will get it done tonight. If you have any questions about the exam, let me know. And don't forget about that Dropbox. There will be no assignment on Thursday, just the exam. And it'll have 60 questions on it, and I'll drop the lowest one. And no assignment next Thursday because of Turkey Day. Yes. So, go forth and prosper.
Aren't wisdom teeth not really the same category? Because we don't really use our muscles in our ears and we all already have. We can still use our wisdom teeth.
But if you take that wisdom teeth out, you're gonna survive just fine. So if they don't serve, they do serve a purpose while they're in there. But if you took them out, it wouldn't matter. Yeah. What did you say? I know. I had to have my two removed when I was 13. It was horrible. And my tonsils and... Oh, that's the worst.
Does your son watch Dinosaur Train?
Oh, nonstop.
Yes.
Dinosaur Train, Dino Dan.
Does he know the contract? The A to Z song? Do you know that?
I don't know. I don't even know that one.
It's a Dinosaur A to Z song.
We have a Dinosaur A to Z book. I don't know that we have the song. I'll have to look that up.
Look it up.
I think he would like that. Yes.
Study guide. This is what I'm
I would you just put that in. I'm just trying to...
Uh, regardless, let me see
So,
where you're going.
It was actually really fun.
That's the old one.
Right.
I got that one.
Okay, I haven't put up a new one yet.
Oh,
I haven't put,
something else.
yeah, that's something else. So you're okay.
What chapter is this?
It's gonna be, no. There's the very, very end of six.
Oh, okay.
So mostly everything that was on the old study guide, I'll probably pick out a couple of things, and then there'll just be a couple of questions from.
Okay.
I'll figure that out later. Thank you. For the, yeah, and I'll send it over to, let me put that on my to-do list. I will actually open up my my to-do list.
That's your picture.
Yeah, that was me 4 years ago. Completely different.
Completely blonde.
I was. Yeah, you know, when I had my kiddo, I didn't realize how much I wanted to look like him until yeah, he could talk about it, and he's like, he likes my hair dark. I like my hair dark. Exam for Friday. Okay. Got it.
And that open drop box, you can, I can just submit it through there.
Yeah.
Okay, they can do multiple attachments. We'll see.
Ha 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 ha. Oh, that's my to-do list. I hope there's nothing creepy up there.
It's almost as big as my to-do list.
Yeah, that's my calendar. That's how I keep track of everything in my life.
For the lab, on our grades,
Yeah.
a lot of them stay closed. I don't understand.
Well, he hasn't put the grades in for like half of them. We didn't know. Sorry. Like,
But some of, but I think Thomas does them, but I didn't understand
I
it.
think
because
I'm like,
some of the things I know I've done, they stay closed and there's no grade, but then there's.
Drops.
Oh, I thought it said closed.
Yeah, the dropped one, that won't count until the very end, because what's going to happen is there's 13 assignments, and we will drop 3, so we'll take the highest 10. And then on the quizzes, it says drop for 2 of them. So
Okay.
it'll drop your 2 lowest quizzes.
I was
And
wondering
there'll be
that.
also
I-
6 bonus.
well, that's because, well, when I go to my springboard, it says like 1 quiz not attempted. So I click on it, thinking it was going to be for this week, the carbon footprint one, but it's for week 12.
They're probably just sporadic because
Yeah, I don't
there's
know.
going to be 3 somewhere within the
No, because it
semester, but
normally
there
tells me
still aren't
like
any
for the
grades.
next week. But yeah, from like lab
Let
6
me-
or 7, we haven't had grades. I'm a little worried.
Yeah, I follow my grades.
I'm
I know,
not
good
trying
for
to
you.
Get him in trouble.
No, you're
but-
not.
I was freaking out,
He's
'cause-
new. He needs to learn how it works. It's okay.
I took the lab quiz for this week.
Yes.
It wasn't listed, one was listed for this week. It
Okay.
was not listed for 2 weeks from now.
Yeah.
Well,
Let me
12. Okay,
Yeah,
because like I'm not about to take.
let me find out. Let me look at it.
biomagnification, I think. it
Yeah,
is.
like is that the one I gotta study for?
Okay, let me
And
check
on
them.
here it says that it's the carbon footprint.
Yeah. See, that is not the quiz that we should be taking.
You guys are doing biomagnification this week,
No,
right?
we're doing carbon footprints.
If you go back one page.
At least that's what the syllabus is telling us.
Yeah.
You guys didn't do the one with the Hershey's Kisses this week?
We are
We
going to
have
lab
lab
now,
now.
so.
We're going to
But
lab
last
now.
week we did the
Bugs.
The termites,
Yeah.
not the termites.
macroinvertebrates, yeah.
Okay, I live there near Yellow Creek.
Yeah,
I'm never going in the water
week
again.
11
Like,
is what we're doing.
No, that looks right. The
but isn't week 11 this week? The carbon footprint lab?
Yes, but we move them around because the carbon footprint in the human population, you're going to do those 2 in 1 week, so that
Okay.
you have a whole week to do your presentations, because it wasn't fair to do like one lab 1 week and make half the groups go the first week, and then do the next lab and make the other half the groups.
Okay.
'Cause then some
Yeah,
people
that
had to-
carbon footprint one, it was saying we had to go online and stuff, so it
Yeah.
was, okay.
Yeah. So
So we're
you
doing
don't
12
you don't need
this
to do
week.
that one yet. Yes, you're doing 12 this week.
Okay.
We flipped them around a little bit, and I'm sorry, I probably didn't explain that very well. That would be my fault. I'll take blame. You don't have to lynch Thomas over it. It's my fault.
They don't tell us anything. But yeah, no, the whole grade thing just kind of... And then for our grade in this class, there was that 1 week where you let us make up one of the...
Yes.
Now, is that going to get counted twice, or does it...
Uh,
Because like mine says out of 100 now, and I know some people say out of 90 because I re-entered my, the one because it didn't work out, I guess.
I think that where I'm at right now is that I have 100 points worth of assignments, and I'll take it out of 80 because I gave a makeup. I gave that one makeup for earlier when
Yeah.
I screwed up the Dropbox, and then I'm doing a makeup right now where
Okay.
you can submit any one of them.
Okay.
And so if you don't have any that count against you, you already have 100% of those 80 points. And if you need the points...
So it's going to be 80 because like right now I have
think
85 out of
so.
100.
I think
so. I
so.
didn't know.
Yeah.
Okay.
Yeah, I promise. It'll bring your grade up. If you've got 85, you're gonna do great.
That my son always comes and bothers me when I'm listening. Like when you had to do the storm one, I was like, I know how she feels.
Yeah.
You know how she feels.
You know what is the hardest thing for me is getting anything done at home.
My whole bachelor's program's online. I don't know how I'm gonna do it.
Oh my gosh, you almost have to like plan to go somewhere else.
Well, that's what I was thinking. Like how I, have, like because I work, I went Tuesday nights off, whatever. I think I might just have to
Yeah.
send him to school.
I'll
He'll
tell you
be 4 in
something.
April, so.
I watch him on Wednesday nights, and
Oh, I do that all the time.
And I sit in my office from 8 until 11 p.m. and do my homework
Yeah.
because I can't get him to watch him otherwise.
Well, he goes to bed at like 8, so usually like Sunday nights I'll try and finish it, since
I
we
never
have
get
until...
anything done at my house, so it's like I see like there's laundry and
Oh, see, I
dishes
live with my
and
parents,
stuff.
so I don't do any of
Oh
it.
my gosh, you're so lucky.
And I'm a chef, so I cook all day.
I'm so thankful for your homework.
It doesn't
And
bother
my
me.
husband, they all...
He just tries to type on the computer with me, so we're gonna get him a computer for Christmas.
Yeah, seriously.
Do your own homework. I'm doing
So
mine.
you have plenty of other things, learning things.
Okay, well, thank you for letting me know about that, and I will get everybody up to speed. That's the things I need
Well,
to
it's
know.
just because
I'm in
I
charge
like
of it,
to
and I
keep
need
track, and when it says 47, I start freaking out because
Yeah.
I was like, okay,
I don't blame
did
you.
did I miss one? Like,
No, I
do
totally
that
get
every
it.
week?
I totally get it, and I'll fix it.
Okay.
I will. Thank you. Oh, I should have turned off my microphone. Sorry.